we want to look at domain of radical functions, those radical functions that have that square root in the function. I want to talk about real quick the parent function graph for square root of x. If we think about this, we have it starting at 0 and going to infinity, roughly in that direction. Okay, so why does this matter and why is this important? Because notice that we have no negative values here. And that is because if you remember, when you take the square root of a negative number, it actually generates an I, or imaginary number. So you're not going to see that on this graph. And so when we start talking about domain of radical functions, we can only consider those that would give us a positive number underneath this radical. Well, in mathematical terms, how do we say we only need positive numbers, or it can't be negative? That's where we use the greater than or equal to signs and the inequalities. So we want it to be greater than or equal to 0. Can it be 0? Well, what's the square root of 0? It is actually 0. So we can have a value that is equal to 0, but if we start going into the negative direction, we get into imaginary, so we can't have the negatives. Okay, so what we want to do is take this number under the radical, it's called the radicand, and set it greater than or equal to 0. Can you do this every time for a radical expression, a square root expression? Yes, you can. So this would be the basic format. It would be denominator, it's greater than or equal to, not denominator, the radicand, my bad, the radicand should be greater than or equal to 0. Okay, let's solve this inequality. So subtract 1. X is greater than or equal to -1. Now, how do we write this in interval notation? Again, I like to use graphs. So I have -1 here. If I was to shade this, it would go to the right. And would I have an open or closed circle? Well, I have greater than or equal to, so this would be a closed circle. And if I want to turn this into interval notation, I would start from left to right, or smallest values to largest, or where does it start and where does it stop. So if I go from left to right, the first thing that I'm going to get to is -1. And because this is an equal to or a closed circle, I'm going to have a bracket there at -1. And then I'm going to continue going on and on. So this is going to be infinity with the parentheses. Okay, so that's an example of the domain of a very basic radical function. Let's do one that's a little more complicated. Let's say we want to find the domain of f of x equals square root of -2x plus 3 plus 1 on the outside. So I threw this in there because I want you to understand that when we're doing the domain of a radical function, the numbers outside that radical are really irrelevant to the domain. The only thing that's going to limit the domain and make it something other than all real numbers is what's under the radical. Okay, so let's set it up similar to what we did in this first example. We've got -2x plus 3, the radicand, and we're going to set that greater than or equal to 0. So what's under the radical, we set greater than or equal to 0. Now let's solve. So subtract 3. -2x is greater than or equal to -3. And then we're going to divide by a negative. So we must remember those inequality rules. If we divide by a negative, here, the number in front of the x, or the coefficient, you have to flip the inequality sign. So instead of greater than here, we need this to be less than or equal to. And then 2 negatives make a positive 3/2. It's important that you understand that this number here on the right-hand side is really irrelevant when we start considering whether we need to flip the inequality. This one doesn't matter. It's only the one that we're dividing by. If that number is negative, then we have to flip that inequality. Okay, so let's think about this graphically. We have 3/2. And we have this less than or equal to. So which direction would we shade here? We need numbers less than 3/2. So we're shading to the left. And we still have the equal to. And again, this is the format for setting up the radical inequality. So it's going to be the same thing every time. We're going to have a closed circle here. So because it can equal to that number. All right, now how do we do interval notation? We're going to the left, so that's going to be negative infinity. And then we're going all the way up to 3/2. And then we're going to have a bracket. Okay, so again, I have a bracket, but notice what happened here. Because I had a number that was negative in front of the x, it flipped it around. So now I'm going to the other side. I'm going to the negative infinity direction, then up to that number. So that would be how you find the domain of radical functions when it's given to you in function notation.